Hello and welcome to today's SFPE Perspective webinar on the role of emergency responder communication enhancement systems in fire and life safety solutions, sponsored by Edwards. This is Ryan Tunkel. I'm an SFPE project coordinator and I'm going to be moderating today's webinar. Before we get started, I'm going to go over some information in regards to the webinar logistics. First, all participants will receive a certificate of attendance for 1 PDH by attending this webinar in its entirety. Please note that in order to automatically receive your PDH, you must complete the post-webinar survey that is located in the e-learning portal associated with this webinar. By doing so, the PDH certificate will be automatically populated in your SFPE e-learning profile. We do not provide copies of the speaker's PowerPoint presentations. However, the recording of this webinar will be available to all our attendees in our online learning management system, which is the same place where you registered for this webinar. Additionally, you can ask our speaker questions by writing it in the question and answer pane, as opposed to the chat room in the webinar dashboard. Again, please submit any questions in the question and answer pane, and our speakers will have a chance to answer them at the end of the presentation. So we'll get started. Today's speakers are Timm Weber and Dennis Burns. Timm Weber is Strategic Accounts Director for Edwards, a carrier company. Timm has been in the fire and life safety systems industry for over 30 years, starting in the field as a technician after graduating with a degree in engineering technology from ITT Technical Institute. Timm is a member of National Fire Protection Association and National Institute for Certification in Engineering Technologies in Fire Protection Engineering Technology and Fire Alarm Systems. Timm's experience in the life safety systems industry has seen technology evolve from simple audible-only horn solutions to modern, complex solutions that involved integrated fire alarm voice systems, direct recipient mass notification systems, and IP VoIP connectivity. Timm's focus is to educate building owners and facility managers on the latest life safety technologies and code requirements to help ensure effective response and management of different emergency events, such as fire, active shooter, extreme weather, chemical spills, and more. Dennis J. Burns is the Director of Public Safety at ADRF, in charge of the National Public Safety Strategy for North America. His responsibilities include developing the corporate public safety strategy and product solutions needed for emergency responder communication enhancement systems to deliver maximum market share and revenue. He's also charged with enhancing the awareness of ADRF's public safety products, technology, capabilities, deployments, and the overall ADRF brand. In addition, he works closely with AHJs throughout the country to ensure ADRF has the right products and services to meet current requirements and any future changes within each jurisdiction. Dennis is also the interface between ADRF's US-based sales, DAS engineering, and technical support teams and Korea-based product development and manufacturing teams regarding public safety products and technologies. He has more than 27 years of experience in developing direct and indirect new business strategies within the wireless industry, with a particular expertise in first responder public safety communications. Dennis is an active member and strong advocate of the Safer Buildings Coalition and elected to its board of directors in 2019. He's also a member of the Code and Standards Work Group and Public Safety Technology Work Group of SBC. In addition to SBC, Dennis is active with many state fire alarm associations throughout the US, UL Labs, and NFPA. Prior to joining ADRF, Dennis was a regional sales director at Cobham Wireless, where he was responsible for delivering and driving corporate revenue goals via new direct and indirect relationships with potential clients in both public safety and commercial cellular. He previously held senior leadership roles in IXI Mobile, AT&T, Singular Sprint, Palm, and Bell South Wireless Data. Dennis holds a bachelor's degree in Management Information Systems and Services from the Southern New Hampshire University. So with that said, please welcome Timm and Dennis.
Thank you, Ryan, for the introduction. And thank you, everyone, for joining us this morning for this session around emergency radio responder systems. I would also want to welcome, Dennis, just like Ryan did. And back in April of this year, Edwards, we started a strategic agreement with ADRF, and ADRF has obviously been in this industry since the 1990s when they were established in Burbank, California. And through the vetting process, we came to this agreement with ADRF because they are an extremely knowledgeable manufacturer and producer. And through this presentation, you'll see obviously from Dennis's credentials and what we're going to go through here, why emergency radio responders, they're important, where they're supposed to be, the interconnectivity and the elements, which Dennis is going to go through. And we went through that vetting process because it was obviously a specific need for our channel partners and continue to deliver life safety comprehensive solutions to the market. So just to remind you, and Dennis, you could change to the next slide real quick there. Edwards is, Dennis, you happen to change the slide for me just one moment. There we go. Thank you. So just to remind everyone, Edwards, we're a longtime life safety systems manufacturer, all the way from small independent little panels and life safety systems to complex systems that go into multiple large facilities and things of that nature. And with this partnership with ADRF, it just continues to build out the life safety solutions product line that we're offering through our channel partner network out there in the market. Go ahead and change the slide there, Dennis, one more time. And obviously, we have our newest flagship product, EST4, which we brought to market back in 2019, along with our other midsize and small level IO series product, along with LED technology, new smoke detection products that are meeting the UL 217 requirements that are now enforced by the UL standards and that are coming into effect next year now that UL pushed that requirement out for smoke detectors, incident management solutions, and now expanding the offering with the emergency rate responders communications with ADRF. And at this point, I'm going to turn over, as Dennis and I have joked here about this presentation, I'm going to turn over the presentation to Dennis so he can continue to do the heavy lift, and I'll be in the background and as things progress. So Dennis, it's all yours. Thank you.
All right. Well, thank you, Tim. And thank you, Ryan, and thank you to the SFPE. We appreciate the time and everyone joining us here this morning. So yes, we're gonna get into it here. We're gonna talk about just what is whether you hear it as an ERCES or an ERRCS. I mean, it's the same acronym. So it's either radio coverage system, or it's a radio communication system, emergency responder communication enhancement system. It's known by several different things, but usually ERCES, emergency responder communication enhancement system, is the one that you see out there the most. So we're going to talk a bit about these systems. We're going to talk about some of the codes and the standards that drive these systems, and then we'll spend some time talking about the market, kind of where some of the construction is happening, and then some of the different steps that you take when you're deploying these systems, who some of the stakeholders are, and the critical folks that you need to engage to ensure a safe and smooth deployment. Because at the end of the day, it's all about that certificate of occupancy and making sure that your building has first responder coverage throughout. So so let's get into it. So let's who are the stakeholders, right? So they come in a variety of different shapes and sizes, but some of the things we're going to be talking about here today a lot is the really the influencers, right? So NFPA and IFC, you have your different building codes and fire codes. And fire code, it hasn't been around all that long, right? It's not like sprinkler code. Fire code, was first published, the first model code, in 2009. So really just over a decade that fire code has been out there and published. And just so you understand, when you look at fire code, whether it's NFPA or IFC, anything that's happening out there at the local jurisdiction level, it comes down to do you have first responder coverage? And if you do not, then that's where NFPA and IFC come in, because they talk about what are the requirements for both new and existing buildings, and we'll get into that here in a little bit. We'll talk about the some of the different influential parts of the code that drive these systems. But in addition, you do have the UL as a standards body, because it's a lot of those standards, and we're going to talk a bit about UL 2524, which is that that highest level of code compliance with that type of certification, and because now that's moving its way into the new model codes. It's in IFC 2021. It will be in the next version of NFPA, which is NFPA 1225, which will be published in 2022. So we'll talk a bit about that, and then some of the key other influencers like FCC. Sometimes the HJs are also the FCC license holder. Sometimes they are not. Sometimes it could be a consortium. And the wireless carriers. I'm sure many of you have heard of AT&T Band 14, but you also have public safety LTE, from other carriers, and that's becoming in the 700 megahertz and LTE band. When you want to do you want things like floor plans and additional bandwidth capabilities. That's where some of the LTE technology comes in. So some of the other stakeholders that you have, I keep mentioning AHJs. They are the authority having jurisdiction. I'm sure many of you on the phone are very familiar with who they are. There's about 3,300 across the country. So you have to there's a balance here, right? Because you have your national codes, you have your state codes, but then you have your local code enforcement. So that's why the AHJ is critical in this whole process that we're going to be talking about today, because you want to understand what frequencies are involved, as well as the code year that they are currently adopting, whether it's NFPA 1, 1221, IFC, whether it's 2021 or 2018, exactly what is the code year that's being driven at the state level and the local level. And of course the importance of the first responders. At the end of the day, it's all about they press that button. Is the system going to work, and are they going to be able to communicate? And in addition, not just on the first responder side, but also the building inhabitants, right? And making sure that those buildings are safe for the folks that are inside those buildings. And who makes all that happen? Well, it's folks like Edwards, and dealing with with their strategic partners, other system integration companies that are out there, throughout the country. They're the ones who are getting involved and doing that benchmark testing to understand, hey, is a system going to be needed? And it's it's those SIs and partners that Edwards has, and some of their their dealers that are out there that can help to understand if a system is needed, what are the requirements, and then make sure that system is installed and meets all of the requirements of the local jurisdiction. So as we talked about NFPA and IFC. So in UL is a standards body. So all of these codes and standards, they influence the the national level. So when you have NFPA, currently NFPA 1221 is all about emergency responder systems. And more specifically section 9.6, which talks to a lot of the requirements. The fact that you need 99% in those critical areas, exit passageways, stairwells, basements, all of those areas that are most critical for an emergency. In IFC, it's all about section 510, and that also talks to the requirements of these systems. So if you need a first responder system, it's those national codes that are driving what you need to have. Things like pathway survivability, signal strength, a DAQ, delivery to audio quality of 3.0 or higher. So making sure that, as I said, when the first responder presses that button, the communication is getting through. And as I mentioned on the UL standards level, a lot of those standards that are being developed, whether it's 780 pertaining to lightning protection, or 2524 that we're going to talk a bit more here in a moment. All of those things typically work their way into the national model codes. All right, so let's just take a look at some of the the different elements here, right? We talked about IFC section 510, and again, that's specific to emergency responder systems. On the NFPA side, you have a number of different codes. We're not going to talk about NFPA 70 and some of the electrical codes. We're going to focus in on life safety and fire alarm signaling. But depending upon the state, you do need to understand, and again, that's your engagement with the AHJ. To understand is is it NFPA 1? Is it 2016, 2019? Is it is it NFPA 1221? What is the code year? Because right now code year for NFPA and IFC, they're on a 3-year code cycle. But we'll talk about here in a moment, when NFPA moves to 1225, it'll move to a 5-year code cycle. All right, so you need to understand what the code year is at the local level, because that drives all the different requirements of the system, whether it's battery backup, pathway survivability, things that we just talked about. And then of course FCC, right? You want to make sure any equipment that you're out there deploying, does it follow the things here like around Part 90 rules. There's a lot going on regarding noise in these systems, because requirements are driving more systems to be deployed, and that's where things like filtering and noise become really critical. Safer Buildings took on the initiative to put together a no noise task force, and a lot of that is working in conjunction with folks from the FCC and other industry professionals, so that you know that when systems are deployed, it's meeting the noise standards that are required by the FCC. So let's let's go through. We'll talk more now about UL 2524. So this is a standard that was originally approved in October of 2018. Then there was a revision in February of 2019, and this is very specific to certify as a system. Okay, it's all about emergency responder radio communications. It's the BDA, it's the repeater, the annunciator, so the annunciation of the alarms per NFPA and IFC, as well as the battery backup. So battery backup, whether it's 12 hours, 24 hours, 4 hours in a generator, 2 hours in a generator, so whatever the case may be, but it's it's certifying all of that as a system. We as ADRF, we were the first and only that has achieved the new enhanced UL Smart Mark. We're very proud of that. So if there's a code official in the field and they want to understand, hey, is this equipment UL 2524 certified? All you gotta do is just take out your smartphone, scan the QR code, and it'll go right to a UL product IQ certification page, and it lists all of the products that are UL 2524 certified. So very easy to understand. Hey, does this product meet that highest level of certified code compliance with UL 2524, and of course with the ADRF product it does. So let's now just talk a bit about we're going to talk now about NFPA and IFC, and really the takeaway here is just realize it's not just new buildings, right? It's new buildings and existing buildings. There's some grandfathering going on with some existing buildings depending on the state. We'll talk about that here in a few minutes, but just realize that when it comes to first responder systems, whether it's a new building or an existing building, and again, the HJ, understanding those local code requirements, you have to show that you have first responder coverage within that building. Because if you don't, that's when you need to put in a first responder system like what we're talking about. The LEED certified buildings, great for energy efficiency, not so good for RF, right? Because you have RF that's outside, in the macro network, and you need to take that signal from outside and bring it inside the building, and that's why it's called distributed antenna, right? Because now you have your passive antennas throughout the building, so the signal outside, donor antenna up on the roof, which then comes down into either a BDA or a fiber head end, which then distributes that signal throughout the rest of the building. And again, as you see here on the screen, it's both new and existing. On the IFC side, so IFC today, it has been adopted in 42 states, as well as DC, the District of Columbia. Some that are grayed out here are really NFPA specific. With state of Florida, as you see grayed out there on the lower right, NFPA 1 2016 is what drives their fire and life safety systems. But on the IFC side, just like NFPA, right, it's new and existing buildings, right? So it's not just new. If you pick up a copy of NFPA or IFC, good light reading. The 510.1 is all about new buildings. 510.2 of IFC is all about existing buildings. Okay, so it's very important that you understand that this is both new and existing. And again, there's some grandfathering that's going on. Because of the pandemic, there were many states that were going to require existing buildings to bring up to the latest and greatest of fire code and with these systems, and a lot of that has been relaxed to 2025. So again, understand the HJ, and you're asking these questions so that way when a system is deployed, it meets all of those requirements, because it all comes down to that certificate of occupancy, right? So if you get to the you're on the goal line, and it's it's first and goal at the 2, and you haven't put in the proper system, the code official is not going to sign off on that system, and then you're going to have to make some changes. So it's good to do your homework up front, understand the code year, understand the requirements, the frequencies for both new and existing structures, for IFC and NFPA, and then go from there, and good things will happen. So I just wanted to bring out, and I'm just going to highlight a few here as far as local code requirements, because there are, many local jurisdictions which differ. And in many cases, the local code requirement is even much more strict than the national code requirements of NFP and IFC. If you look at, say California, right? California, IFC, based, but they delete Section 510 of IFC, and they have their own Chapter 5 version, within the California State Fire Code, and of course a lot of Chapter 5 really, it's very similar to Section 510 of IFC, but just know that they, the state code, in Chapter 5, they have their own version of 510, let's say. And then, depending upon where you are, and I'm highlighting this here, a few areas of California, and really the takeaway here is just, you must understand, what not just the national codes are, but what the state codes are, as well as, what are some of the nuances at the local AHJ level, because every AHJ, let's face it, they interpret code slightly differently. So the good news here is that, whether if you're working with, with Edwards and their partners in ADRF, we can help navigate, a lot of those waters with the customers. Good case in point here, as you see at the bottom of the screen, Northern California, whether you're in San Francisco, San Jose, Santa Clara, they have a couple of unique, with an addendum G, where they not only want you to put in an active system, but they also want to monitor the passive side, right? So they want to understand, hey, if there's an issue with the coupler, if that antenna is no longer communicating and not providing coverage within that building, they want to know that there's an issue, with that antenna. So the good news is certainly we have solutions for that, can provide either simple monitoring or monitoring and control of the entire passive side of the system, and then in more and more, a lot of the AHJs are starting to mandate what's referred to as EPO, emergency power off. Okay, and some depending upon the jurisdiction, they want it. They have their own kind of version of emergency power off. But at the end of the day, what it comes down to is if there's going to be a rogue system, or if there is a system out there that is providing interference, and maybe it's causing issues with the public safety system, or potentially the cellular system, because some of those bands are very close. So that's when filtering becomes real key, especially when you're talking about FirstNet 700 band, upper 700s, when you're dealing with the 850 band of cellular. You need to make sure that you have very good filtering, and if there is an issue with the system causing interference, the AHJ wants the ability to flick a switch, shut off both the BDA, and in many cases the DC side as well, to turn off the battery backup. So again, just know that there are a lot of local requirements that are out there. We were talking about California, a few others here to understand is that in Florida, you have to, when you're putting in a system, they also have, different mandates at the local level. So if you're, depending upon where you are, if you're in Broward, they have a BDA committee, and so they publish, requirements, specifically for their BDAs. Miami-Dade County, same thing. Manatee County, same thing. So it's good to understand. As we were talking about, have a relationship with the AHJ, the local code official, understand what their local BDA requirements are, what modifications that they may have, and because in Florida, you need to be able to expand the system, to operate on as I mentioned earlier with AT&T and FirstNet, band 14 on that 700 megahertz spectrum. In Massachusetts, we talked about UL 2524. There's a lot of jurisdictions now, very many. let's say there's quite a few of them that are now mandating UL 2524 as a requirement. And again, we can help you with that. Edwards and their partners can help you with that. So just know that the list is growing, right? Because now with IFC 2021 and Section 510.4, it talks to specifically UL 2524. So all of those things become critical. And then the last item here on Travis County, in Texas, just realize that at the local level, a lot of times the requirements go beyond that at the state level. All right, so let's see. So let's just talk about a few of the code changes. I mentioned NFPA 1225. That's a consolidation effort. With 1221 and 1061. That's in the final stages now of being approved. The first edition that will be published in 2022, January of 2022. Even though IFC 2021 was just recently approved, we're already, as part of Safer Buildings and the Codes and Standards Committee, we're already looking at some of these changes and enhancements to 2024, because IFC 2024, now you look at high rise and 75 feet and above, and that some of that's going to change as if it gets approved. What's on the table right now at 12,000 square feet and above. So those are all things that are being looked at as part of the new changes and initiatives. The noise, as I mentioned, and we'll talk about it here a little bit more in a second. That's becoming more and more critical because you need to make sure that your system from a noise figure and just causing interference with other systems that are out there as more systems are deployed. This is the actual verbiage from 510.4 under the technical requirements. As I mentioned, UL 2524 is now part of that. So you must have a UL 2524 certified system at the national code level, and it is going into NFPA 1225 as well. I've talked to the noise piece. I mean, that's critical. I mentioned what's happening with IFC 2024, but then again, as I mentioned, these local. I mean, there's some changes that are going on in the state of Michigan that have already been approved. North Carolina has recently approved. All new buildings, 7,500 square feet and above, must have first responder coverage. So you have to. That's where doing this RF benchmarking, doing this testing. To understand that you do have first responder coverage, because if you don't, and you don't meet the criteria of 99% of the critical areas, 95% of everywhere else, that's when a system is going to have to be deployed. As engineers, I thought it was important just so you understand some of the potential changes that are coming down the path here with 1225. And if you want to, anyone wants to have a further discussion, just let us know, and we can certainly do that. But there are some changes that are being proposed for pathway survivability. Okay, and again, these are going into 1225 in chapter 18. As I mentioned earlier, right now it's all about 9.6 and 1221. But as you look at NFPA 1225, it's going to be more about chapter 18, chapter 20 in the appendix. So in chapter 18, if you have a commercial building with a fully sprinklered system, that is NFPA 13, then there's a lot of changes that regarding conduit, okay, for both the backbone and the distribution side, donor and server side of your system. So if you have a fully sprinklered building, you may not need things like conduit. So those are, just so you're aware, some of the changes that are coming down the pike that are being reviewed right now within 1225. So certainly expect some changes to pathway survivability. All right, so let's look at where are some of these new buildings being constructed.
Hey, Dennis.
Yeah.
Hey, Dennis, just to interrupt you real quick. So we had a question here, and it kind of plays into that code piece, and I just wanted to answer it along with you. So the question was from a cost perspective, and comparing a emergency radio responder system to a two-way communication system, the cost perspective. And it's really, in my answer on the fire alarm and life safety side, right? The two-way communication system is part of the fire alarm system. And that typically has a handset or jacks or maybe phones that are physically wired within the stairwells, elevator lobbies, and those types of things. And it's, from a cost perspective, just to answer that question really quickly, that is actually probably a more cost-effective method. However, what's happening from the code perspective, and you can answer this, Dennis, is that it's actually being enforced through a code and an AHJ requirement, because they don't pick up those phones, and those systems may not work when they're supposed to need to be, but their radios are constantly being tested and worked with. So, but go ahead, you can expand on that as you finish up with your.
Sure.
I just wanted to throw that out there.
Yeah, no, absolutely. Thanks, Tim. So yeah, a lot of those fire ground systems and the way things used to be done, a lot of that is being changed, right? So when the days of going into a building and plugging into a jack onto a handset, a lot of that is being phased out. In New York City, they have what's called ARCS, auxiliary radio communication systems, and now it's all about they enter a building and they have a console. And they communicate FDNY and EMS. They communicate on channel 11 and 12. UHF 43 and 484. So now they go into that system and they turn to either channel 11 or 12. And now their radios are going to work because there's a first responder system inside the building. So a lot of plugging into that fire ground system, a lot of that is going away. And because now with these with the code driven emergency responder systems. So those LMR, those radios that are working. I'm touching my shoulder here because a lot of times they have the little handset there on their shoulder. So now when they go in, they don't have to do anything, right? Because, and that's why I was talking about with the HJ and understanding their frequencies, because if the responding authority, is going into a fire in Boston, Mass, that this first responder system has those frequencies in the in-building system. For those first responders. So when they go into the building, everything that's working for them on their two-way radio outside the building is going to work when they enter the building. So that's where a lot of these codes are driving to make sure that as a first responder, police, fire, EMS, they're outside the building, they're inside the building, everything works. All right, so it's not like and that's some of the things that happened in 9/11, what happened in Vegas and Parkland in Florida. In different emergencies, a lot of sometimes these systems they didn't operate. They weren't working, and that's a problem. So that's why a lot of these new codes are driving to making sure that these systems work the way that they should. So that way there's nothing that has to be done on the first responder side. They're using their two-way radio outside their building. They're using the two-way radio inside the building. Because codes and requirements are driving that, so that those frequencies that they're using, all of those same frequencies that their radio is accessing, can be accessed within the building as part of the emergency responder, the public safety distributed antenna system. So thank you for that question. So let's just take I know we're it's 11:33. All right, so we're going to take just a quick look now at so you can see where the dollars being spent, right? Across the different verticals, and clearly, education by far. There's every single day there's schools in the state of Florida that are putting in first responder systems. We have a number of different installs. You pick a county, whether it's Hillsborough or Broward or Orlando or Miami-Dade, Manatee, doesn't matter. The number of systems that are going into that state, as well as education across, whether it's ITS in Houston or there's so many systems that are being deployed at the education level. Unfortunately, we have a lot of these mass shootings that happen in these schools, and they want to make sure that when first responders do enter these types of these crisis situations, that they're able to communicate, and that's critical, and that's obviously why you see education being the where a lot of building is going on, but where a lot of dollars are being spent when it comes to to life safety and security. Clearly 2 to 1 over everywhere else and beyond as to where the dollars are being spent for life safety and security systems to ensure that the students, faculty, staff, as well as first responders when they enter into those situations. And then you can see here on the screen, we won't go through all of them, but where dollars are being spent. There's a lot of dollars being spent on the healthcare side with with hospitals throughout the country. Because doesn't matter what vertical you're part of, national code, local code, state code, mandates that you must show that you have first responder coverage, and if you do not, you must put in an in-building system. You must put in an emergency responder communication enhancement system, so that way when first responders do enter the building, it's going to work. All right. So there's a lot of steps, right? And this is a few that we wanted to highlight so you understand kind of, where do you start and the ultimate end goal, right? I mean, when you first start, you identify a project, and then right when you're starting to get engaged in that project, it could be an RFP process, it could be a relationship that you have on the life safety side already, and you're already working on putting in the life safety system, so now you're talking about taking the those requirements on the life safety side, and you're already dealing with a lot of these AHJs, and say, what, now let's talk about your needs on the first responder system side, and and connecting that first responder system to the overall building's life safety system, connecting that BDA to your EST4 and making sure everything is working cohesively as one complete solution. So you see some of the steps that are here, and again, we can go through these in more detail if you'd like, but it really comes down to who is the AHJ, what code year are they enforcing, okay, what are the frequencies that you need to cover, who's the FCC license holder, right? Because you're going to need retransmission agreements and signatures, things that have to be signed off on as part of that that permit process and the C of O. And then if it is an existing building, or maybe you have a shell of a building, depending upon where you're engaged in the project, you're going to need to do some some RF benchmark testing, right? Because you want to understand, it's much less expensive if you've got to run conduit. And again, some of those, as I mentioned earlier, some of those pathway rules are changing. But if today it's all about what type of building is it? Is it a level 1, level 2? So if you need to provide 2 hours of survivability, especially on the donor side, on the backbone side, it's much better to run the conduit through concrete and up through floors into the into the rooftop now, versus trying to drill through concrete later. All right, so it's good to try to get a feel from a baseline standpoint, even if it's a construction site, because sometimes there's going to be buildings in the way that could impact your RF coverage from the from the macro site at a distance, and how far away exactly is that that macro site, because at the end when you're looking at some of these preliminary designs, it comes down to performance, right? So the signal that you have coming into the building is only as good as the signal that's outside the building. So you're pointing that donor antenna to a macro site, and then that's coming in, and then it's all about filling the building with with RF coverage. So once once you've done some of that preliminary work, and you work with you work with folks like like Edwards on the ROMBOM, and they're going to engage ADRF, and we turn those around very quickly in a day or two, and to provide you with an equipment list, so that way you can get a feel for what equipment needs to be installed. And again, it's gonna differ, based on the size of the building, based on frequencies, because UHF VHF propagates better than say 700 800. So you're gonna need more antennas on one versus the other. Is it going to be a fiber install versus versus a BDA? So all of those things matter. But then after you do a lot of your initial surveys and things, that's when you might have to make some tweaks to design, some tweaks to the equipment list, and then ultimately you're going to finalize that equipment list. The gear is going to get tested, and certainly in the case of ADRF, it's going to get tested at their world headquarters in Burbank, California, before it's shipped out. It's then shipped out to a site, and then it's going to come down to a FCC G rule, which is required by code to do that install and that commissioning piece, and then you have the final, right? You tweak the system. You're then going to walk the entire building with a code official, to demonstrate that you do have the required coverage in 99% of those critical areas, as I mentioned. The elevator lobbies, the stairwells, the exit passageways, to ensure that you're able to communicate when that radio button is pressed, delivered audio quality of 3.0 or higher, and then ultimately the code official will sign off. You'll get your certificate of occupancy, and then the final element here is the annual health checks and maintenance, because code does mandate that they want to make sure that the system, is working on day, say day 366, just as good as it did on day one, right? And things can impact that, right? So, there could be a new building that's being constructed that all of a sudden now, you don't have, good donor signal, coverage, and you have to make some tweaks and changes to the system. That's all part of the complete, system installation process to make sure that it, in those other years, it works as the way that it was designed and the way that it was worked and signed off on, when the building was first completed. Okay, so we went through a lot of the different steps, and again, I can't enforce it enough that engaging that AHJ and the code officials early in the process, that's critical, right? Because you really want to make sure plan for success, right? Because you don't want to have the gotchas, the 11th hour changes and tweaks that you're going to have to make because you were going off the wrong code year, it was the wrong requirements. You needed 800 in UHF and you only planned for 800. All of those things make a difference. And as I mentioned, codes are driving more systems to be deployed because they're mandating that you have this first responder coverage in these buildings, and if you don't, then you do have to put in a system. So noise is critical. I talked earlier about LEED certified buildings, right? Great for energy efficiency, but not so good for RF, right? So it reflects RF, as well as building construction, right? So if you've got a very well built building, it's very thick concrete, and just understanding, you may have great coverage outside the building, or maybe within the first part of the inside of the building, but as you move further in and you have more loss, going through these walls, it is going to, require a system so that you do, meet that 99% of the critical areas and 95% of everywhere else. So, as I said, AHJ is critical, code official, planning for success. So, all of those pre-steps are critical so that you get that ultimate sign off, at the end. So just so everyone is aware, there are challenges, right? Because as I mentioned earlier, every AHJ, interprets code, slightly differently. Every system integrator, does, installs and commissioning slightly differently. We want to make sure that we're leaving, little up to interpretation, right? And that's why, you have that relationship, with the AHJ so that you can ask the questions, regarding frequencies, regarding pathway, regarding battery backup, all of the things that you need to know so that you're planning to put in, the proper system, and ask them, hey, these are your requirements today. These are questions I ask AHJs all the time. I understand what your requirements are today, but what's potentially changing, right? We talked about public safety LTE and FirstNet Band 14. So some AHJs are now starting to look at, okay, well, if FirstNet Band 14 is available outside the building, I want it inside the building. Okay, well, is that something that you're looking at? UL 2524, that highest level of certified code compliance. If you're not enforcing that today and mandating that today at the local level, is that something that you're planning to enforce, right? We talked about IFC 2021. It's going to be mandated in there in 510.4 and also mandated in 1225. But the list of AHJs that are already requiring it is getting larger and larger, every single day. So it's understanding, those types of things, at the beginning, because those are challenges, right? Because you don't want to be walking a building with a code official, and then you don't get that certificate of occupancy, or the building can't open. You're doing the walkthrough on Wednesday because the building is planning this huge grand opening on Friday, and all of a sudden now you need to make changes to your system because you didn't plan. You weren't having those conversations up front to understand the requirements. That's why I say it's critical that you have those discussions with the code officials, understand all of the requirements at the national, state, and local level, and then good things will happen when it comes down to signing off on the system and getting that CFO. All right, so talk about the last steps here, and then I'll turn it back over to Tim to take us home. I thought it was just important so you understand. I mean, this is just a couple of versions, from Manatee County. Manatee County actually has just recently, published, a BDA requirements. You see a summary here and a checklist, that they have, and then you also have to, when you're as part of their permit process, and this is the same in many jurisdictions, they have a form that you complete to show them that you do have the required amount of coverage, and if you do not, then you have a checklist as to here's the type of BDA that you must put in, pathway, battery backup, here's the frequencies, etc. So you want to understand what those requirements are at the local level. So if you do need to put in a system because you don't have the proper RF signal for the first responder system, that you understand what those requirements are, and then you would then ultimately, before the system is turned on, you do need to have a retransmission authorization with the FCC license holder. As I mentioned earlier, sometimes the HJ and the FCC license holder are the same. Many times they are not. So this is just an example of Tampa and Hillsborough County, but you do need to have a retransmission agreement. Depending upon the system you're putting in, if it's class B and has an FCC ID, you do need to enter the system within the FCC database so that they understand where that system is being deployed. Because at the end of the day, it's all about getting that certificate. It's all about getting the that certificate of compliance that says, okay, my building it meets all the codes. I have first responder coverage, and I'm getting the ultimate sign off for that certificate of occupancy. So whether it's existing, made tweaks, new, now they're saying, okay, yes, you can occupy the building and you are good to go. All right, so and again, I think this goes without saying. This is my last slide, and I'm going to turn it back over to Tim. But it's all about communication, right? We've unfortunately it takes some really bad things going on in our country that drives more codes and more requirements and more mandates. But it's all about safety of the inhabitants within a building. Safety of the first responders that enter that building. So when they click on that radio, it actually works, that they can communicate. They have the proper amount of coverage, and that's really what's driving all of this and why we should care, because it's all about safety for the building inhabitants, safety for that first responder, so that they can focus on really the critical nature as to why they're entering that building and reduce their risk, because they actually can communicate with each other. So with that, Tim, I'm gonna turn it back over to you.
Well, you're not going anywhere, because this is obviously a very hot topic for this audience, because there are a plethora of questions here. So we're just going to jump right into these questions, Dennis. So I'm going to blend with Ryan. I know you're there, so you can help as well. But I'm going to blend two questions together that we have. So first, the question is around inspection and testing. Who's required to do the inspection and testing? And part of another question that kind of goes along with it, the individual sees the fire alarm system integrator and the emergency communication responder piece being hand in hand, but they also saw it as part of a security-based solution for emergency responders, not just fire. And really that question there is why is it being pulled into the fire alarm system integrator from that aspect? So kind of answer that together. I mean, I know what I see in the industry and what's going on since emergency radio responders radios have been starting to be pushed into the codes and things of that nature from years ago. So, but I'll let you go ahead and kind of blend the answers of those two items together.
Okay. All right. See, how much time do we have?
That's why we went into the Q&A quickly. Because I still got 6 more to go. We still got 6 more beyond that one. So, all
right. So,
or more actually.
So so to answer your question regarding the annual testing and maintenance, I hate using the word "it depends," but it really does, because every HJ it's a little different. If you're doing testing and annual maintenance in DC, let's say, I mean they have 3 different organizations that they've approved that can do that, that annual testing and maintenance. So it's again, communicate with the HJ, understand what their requirements are when it comes to the testing and maintenance, because a lot of times it's a small number of companies that they're going to turn to, for that testing and maintenance. So you have a lot of consultants that are out there. We deal with them, all over the country, and some of them wear an SI hat one day, and then they have their safety and signaling consulting hat the next day, and they might be representing as a consultant. They could be representing the jurisdiction, right? So that they're not a code official per se, but they are a consultant that represents the jurisdiction, because they want to make sure that the system that's being deployed, it meets all of the requirements of the local jurisdiction. They're going to look at noise as it pertains to FCC, because a lot of times they're working in conjunction with the FCC license holder. And then they're also someone that local jurisdiction would engage for the annual health checks and maintenance. So it really is going to differ. I mean, there's some jurisdictions now which mandate the monitoring full time of these systems. Okay, we have several customers that have incorporated MIB files, and they have NOCs, network operation centers, that are monitoring the health of the the BDA, the distribution infrastructure. So if there is an issue, then they're going to know about it right away. So it does depend on the jurisdiction, but a lot of times even the SI will be engaged to do that annual health check. So when you're going through your process, in that strategic partner or that system integrator that you're engaging with, they're going to be the ones that are approved by the HJ that can do that annual health check and maintenance of the system. So it is a little different depending upon the jurisdiction that you're in, but at the end of the day, they're all performing the same function, right? They're all going out to make sure that the delivered audio quality ratings from day one in the out years, the system is working, is going to be working and operational the same way. So that way there's no surprises when that first responder enters the building. So that's why it's really critical. And then with FPA 1225, there's a lot of detail that is in that new document pertaining specifically to annual health checks and maintenance. Now the other question was
why it's becoming part of the fire alarm system, and from my perspective,
okay, sure.
my perspective that the reason it's in that is, one, due to fire alarm system integrators are ones that are always the ones that are dealing with the AHJs from a system component. One, right. That's how it kind of gravitated into there. And now with the codes, the fire alarm system does have to monitor that emergency radio communication system for, correct me if I'm wrong, it's 7 different points now. Is that exactly what it's being monitored for?
Yeah. So you have,
but they are two separate systems, according to the question here. But they are completely 2 different systems.
Correct.
That are within the building. So we're all clear on that. But one is the fire alarm system is monitoring the status and health contacts that are on that. So go from there.
Yes. So they are they're separate systems that work very well together. Let's say. Okay. So the answer to the first part of the question, fire code is what's driving the requirements. But in many jurisdictions, you do have to, they will mandate that you, depending on the building, like saying if you're in New York, you may need to support FDNY, EMS, which are on the same, NYPD, which typically is in the 460s. You may have private EMS firms. So depending upon where you're deploying, that's also the question you're going to ask. But it's fire code. It's kind of interesting, right? Fire code is what drives all of this as part of overall life safety. But it's they're usually, from a percentage standpoint, they're the least number of folks that are going to be coming to the building during a call, right? Because I mean, police, by far, it's probably greater than 70% of the time it's going to be law enforcement. EMS is probably more like 15-20%, and then the rest being that of a fire emergency. But the as Tim mentioned, they are separate systems, but just know that the first when you look at overall life safety and overall building life safety, the first responder system. So like with our ADRF BDA, that has the enunciation of the different alarm points that Tim was mentioning. So it was 7, it's now 8 with UL 2524 because you had donor antenna malfunction. Now you've actually added another alarm, which is donor antenna disconnection. So there is an additional alarm with UL 2524, but it's taking, like, say out of our repeater, our auxiliary alarm interface, and connecting that into, say, like the EST4, right? So that way, you need to connect to the fire alarm control panel because you have the enunciation of these alarms as an emergency responder system, but then also connecting to the within the fire control room where that fire alarm control panel is, where the first responder system becomes one element that the overall system is monitoring. So they and that's where you take these dry contacts and connect to, say, in this you have there in the center of the screen the EST4. That's really doing the monitoring of the overall life safety system, which the emergency responder system in the BDAs thing we're talking about, it's just one element of that overall system.
Right. Thank you. So I got 3 questions that kind of all asking the same question. And this is more around design guidance. So one is, how would someone go around, how would someone understand the need for emergency radio responder for an addition to an existing facility, right? And the best practices and some guidance, and even playing that into new buildings as well. We kind of had 3 questions around that same topic of how do I go about, major renovations, what's a scenario, what's something that, is there any guidance around that? What are the steps that can be done to be prepared from a designer's perspective of, yes, it's going to be a solution that's going to be needed to be replied. So I'll throw it back at you.
You don't want to take that one, Tim?
I can always try.
So the you have test and measurement gear that's out there, right? We work pretty closely with the folks from PC Talent and Rich, but let's not even mention them by name. So you do have test and measurement gear that is out there, and they have like, say, like a backpack solution, right? You can walk around the building and it will automatically upload signal levels into the cloud, and then it'll help you generate submittal reports that you can then send to the HJ, so you can see where you have coverage holes that need to be addressed. Because like I say, sometimes you may have parts of the building which are okay, but as you get interior to the building, because as I mentioned, you lose signal. Typically you're about every 100 feet of coax, you're losing 3 dB as you go through different thicknesses of concrete. If you've got automation within a distribution center, you're going to lose signal. So that's where it's going to be key. And when you're doing this RF testing, just realize you can walk the building, and you have to take into consideration the walls and things. And because if you're, like, say, a distribution center, you're going to walk a big distribution center and it's wide open. Well, you can say, geez, I've got great coverage. But then once that distribution center is populated with automation systems, shelving, and all those things, all of those impact RF. Okay, so you have to realize that. And there's propagation software that's out there. I know part of this question was design, and certainly we as ADRF, we have our design engineers, and they do a wonderful job. Whether it's IB Wave or RANPlan, they have these propagation maps. Okay, so. And when you go into these, these software programs, you can actually build the walls and, and put the system in, inject signal, and then generate a heat map. So you can see, just how is this emergency responder system going to behave, within that building when it's installed. Okay, because there's different levels, level 1 to level 5, within the software, so that you can adjust. Just how that signal is going to propagate. And as I said, if you're using, like, say, an IB Wave, and there's engineering service firms, our system integrators, strategic partners, these guys, they, ourselves, we do, these design elements every day, right? Because, we build the walls, we put the system in, you can see how it propagates, and then that becomes part of the overall, submittal package, to the AHJ. They're going to look at those heat maps, right? Because, the 99% of the critical areas, you don't want you want nice bright colors in those, those stairwells, the basements. You don't want those darker colors and blacks, because that means you have no RF coverage, right? So that's why, it's those propagation software, doing those site walks and doing some of that RF benchmarking with test and measurement gear. All of those things become critical when you're talking about the overall design of the system.
So in large buildings compared to small buildings, there was a question here: is could there be a need for multiple systems for large applications versus a single system? Would that be suffice? So what is that from a design perspective?
Yeah. So the just on the screen there, you see a passive BDA repeater from ADRF, and the if you've got a whether it's a half watt system, a 2 watt system, 5 watt system, you're going to look at the overall size of the building, and you could have a simple BDA, which again, depending upon building construction, it may cover 200,000-300,000 square feet. And as you get into larger buildings, we wouldn't recommend putting multiple BDAs. That's where you would get into maybe it's a hybrid system, that we refer to as fiber optic repeater system. RF donor signal in, but then connecting to to fiber remotes. So you could have like a small, call it school campus, or a larger building, maybe getting into the the 300,000 to 500,000 square feet, and then you could have a full blown fiber system where it's signal in, you're feeding into this fiber head end, and then you may have we have systems that have well over 100 fiber remotes that are connected to a head end. So within that one system, you can get into millions of square feet, right? So it all comes down to looking at the the building, the construction materials, so all of that becomes a factor. It's not just a simple answer. You have to look at just the overall size of the building. Is it a campus? Is it does it have how thick are the concrete? What is the construction makeup? And then you can figure out, is it going to be a simple passive system, a hybrid system, a full blown fiber DAS? But it's still going to be a single system, okay? But you're using it a little bit differently, because like I say, if you can get into millions and millions of square feet on a single fiber distributed antenna system.
All right, we got a couple of code questions here, and we'll kind of blend a little bit. So one was on your path of survivability shall comply of level 2 or level 3 for NFPA sections 24.3 1481 2016. So all new installations should comply with this section, ? And then there was another question around, what's the difference between the class A and class B BDA?
Okay, so the answer is, currently in code, yes, that is correct. So if you have a level 2 building, and you need to have 2 hours of pathway survivability. So what used to be referred to as horizontal and vertical, riser feeder, everything in code now, it's all about backbone and distribution. Okay, the backbone side, that's the donor side. Okay, that's where you have conduit that goes up to the roof, donor antenna up on the roof, your RF cable, whether half inch, whatever is in there, that is required by the AHJ. That's all in 2 hour survivable conduit, which then connects and feeds the first responder system. Now on the distribution side, a lot of that's going to depend on the AHJ, right? Because on the distribution side, you might be able to, some AHJs are okay with just half inch Platinum J hooks. Some of them they may want something like a there's UL 2196 approved types of cabling solutions that are out there where it doesn't have to be in conduit and still meets UL 2196 as it pertains to fire and 2-hour survivability. There's companies out there that take 1/2-inch plenum and put it into, like, let's call it a metal jacket of flexible conduit. And some HJs say they may say no to J hooks in 1/2-inch plenum exposed. We want it in that that 1/2-inch plenum type jacket. There's one cable out there called Smart Guard, which basically it takes that 1/2-inch RF plenum and puts it inside that metal jacket, where a lot of HJs are okay with that. So today, backbone side, on the donor side, all has to be in 2-hour survivable conduit. It depends on the code official on the distribution side, and going out to the antennas. So that's why you do need to ask those questions when it comes to pathway survivability on the distribution side, because some will require, some will not. And as I mentioned, there's 2-hour survivable fiber, if it's needed. So on the distribution side, you just connect with the code official to understand what they require, and that way you're not having any surprises when they're walking the buildings and they see J hooks and exposed cable and they're like, hey, where's the conduit? You don't want to have that kind of a gotcha at the 11th hour. And then the other question, which is very different, is Class A versus Class B. Okay, the nice thing about ADRF and working with Edwards here is that we have Class A or Class B in the same product. It's not a different SKU. So what does that mean? So Class A, the way FCC defines Class A, it's 75 megahertz or below. So Class A is really narrow band filtering versus Class B, which is wide band filtering. So usually on Class B, you may have like a 3 megahertz or a 5 megahertz or a 6 megahertz passband filter, and then all of the frequencies that are within that start and stop of say 3 megahertz are going to pass through the system. So some HJs only want Class B. There's some HJs that won't allow Class B, will only allow Class A. So again, it all comes making sure you're having those conversations with the code officials, and we can certainly help you with this, because on the Class A side, you're actually programming in into the software what the uplink frequency is, what the downlink frequency is, right? And then it's just that uplink and downlink which are going to pass through the filtering and pass through the system. Everything else will be filtered out. So that's really what it comes down to, right? With Class A, narrow band, uplink, downlink, programmed into the software, can be changed, right? So if the HJ, if you're on 800, which is the most prevalent, and they add frequencies, not a problem. You just you can add those frequencies into your system. I mean, with us, if they're adding the support for band 14 later, not a problem. You just go in and you make those changes within the system that you have within the BDA, and now you can start transmitting the upper 700s for band 14 and public safety LTE. So it really comes down to broadband passband filtering 75 or above versus narrow band filtering. It might be 12 and a half, 25, different levels. And that's how the FCC looks at it. 75 and below, 75 and above for Class A versus Class B.
Right, which can be confusing because Class A and Class B in the fire alarm systems world is a completely different response. It's all about the actual wiring method. Has nothing to do with frequencies. So
yeah, and it's actually even getting more confusing because you could say some people out there you have like channelized Class B, right? Because there's some jurisdictions, if you have like a system which has a very tight group delay, you may need to have like a 150 megahertz Class B filter, but it's kind of like a channelized Class B in the way that it works. So it can call us, but then we'll walk you through it. But it can get confusing. Yeah.
All right, so we're 10 after the hour, but we're gonna throw one last question, which is just going to be an easy one at you, and then Ryan can take us home.
Right.
So the last one was state specifics around sales, design, install, and service from a licensing perspective. What are you seeing across the country on being able to do that?
the easy part, well, the good news here is that, the two folks on the phone, representing, Edwards and ADRF, we can help with all of the above, right? So that's the good news. So, reach out to us and we can certainly walk you through it. But one thing that I will point out, because this is a mandate, by code and per FCC, is G-roll, right? So we mentioned that general radio operator's license. So that is one licensing aspect. When you're looking at, design and the, install commissioning, ultimately, it's that P, you need that sign off on a someone that has their G-roll, the general radio operator's license. And one thing I will mention, Safer Buildings has a new guide that's going to be coming out, which is all about reference and study guide pertaining to these systems. And there's folks out there like a NICET, which actually it has developed and is developing. I mean, they've already developed their level 1 technician certification, and there will be like level 2, level 3, and then as well as a design element of certification. And that's all about trying to level the playing field here so that everyone has the proper set of from an education standpoint, how to design, how to install. So, those certification classes and those certification requirements are going to be a great way to really elevate, everyone when it comes to making sure that these systems are designed, installed, and commissioned, properly. So that's just to mention a few things that are critical.
Thanks, Dennis. Thanks for working with us and getting this presentation together with the SFPE group. So, Ryan, it's all yours. You can
Great.
close
Thank
us
you
out.
so much. I'm very glad that we had the time. I was not expecting you to be able to get through all those questions. That was really quite impressive. So thank you, Dennis. Thank you, Tim. That was a great presentation. For anyone that did join us a little bit late, I know some people had to come in a little bit late, it looked like. There is going to be a recording up on our website, so you'll be able to see the entirety of the webinar, including all the questions. So thank you to everyone that attended today. Thank you to everyone that asked such great questions. If you do have any problems getting your PDH or accessing the online recording, please do reach out to us and we can help you with that. And so with that, I'll let everyone get on with their day, but thank you again for joining us and have a great day.
Thanks,
Thank
everyone.
you. Thanks, everyone.